Okay, rolling. So the formulas are not on the board yet, those Sxx, Sxy. We'll get there. Eventually, though, what we want is that B1, the slope of our best fit line, is going to be Sxy over Sxx. Okay? Think of a regular slope as like change in y over change in x. So that's not exactly what's happening here, but I see like the y and the x, so a little bit. Okay, so first of all, let me figure out x bar. So x bar, and I'm not going to show the calculation. I just need to add these up and divide by 3, right? So 1, 2, 3 is 6, divided by 3 is 2. So x bar is 2. I'll need that for my deviations. And y bar is 3, right? 4 and 5 is 9, divided by 3, so y bar is 3. Okay, so I want to know both of those things for these deviations. So let me show these deviations. I'll show the subtraction. So x minus x bar, that means 1 minus 2. And so we get -1. Okay. X minus x bar when x is 2. So that means 2 minus x bar is always going to be 2 here. So 2 minus 2 is 0. And 3 minus x bar, so 3 minus 2 gives me +1. Got that. Now we'll do the same thing. We'll do the deviations for each y. So y bar is always going to be 3 here. So when y is 3, I'm going to do 3 minus 3, which is 0. I'm going to do 1 minus 3. And so get -2. And then I'm going to do 5 minus my y bar. So 5 minus 3 is equal to +2. Okay. Now let me do these columns. So this one, I'm just squaring whatever's in this column, right? So these deviations squared. So -1 squared is 1. 0 squared is 0. And then +1 squared is another 1. Okay, so we've got those things. And then over here, I've got the x minus x bar, so the x deviation times the y deviation. So here I've got -1 times 0, which will give me 0. Let me draw that. -1 times 0 will be 0. Then I've got 0 times -2, which will give me 0. And then finally, I've got 1 times 2, which is equal to 2. Okay. Hopefully it's going to be visible here. So most of that's visible. I want to write one more thing, because remember in the Sxx formulas, Sxx, which is this denominator here, was the sum of these things, of x minus x bar squareds, right? The sum of those squared deviations. And so I want to add those up. So beneath here, I can write the sum. 1 plus 0 plus 1 is 2. Okay, so that sum is 2 right there. And then for Sxy, Sxy was the sum of the products of the x minus x bars times the y minus y bars. Oops, y minus y bars. Okay. In other words, the product of this, the sum of this column right there, right? This column is the x minus x bar times y minus y bar. So now I just need to sum all those up. So 0 plus 0 plus 2 is also 2. Okay, so no big deal. So we get both of those. So what that means, let me write this. I'm in dire need of board space, so I'll have to erase some of that stuff. What do I want to know here? Oh, Sxx is 2, and Sxy is also 2. Okay, we're in good shape. So let's finish up, and I might bring back actually, I don't know that I can bring back the share screen while I'm recording, but we'll manage. B1, the slope of the perfect line, and again, remember this red one was sort of just an example, and so I'll give you a spoiler alert. This actually is the perfect line. This is going to be the best fit line because these numbers are going to work out that way. So the slope of the perfect line would be Sxy, which is 2, divided by Sxx, which is also 2, and so we get 2 over 2, which is 1. Okay, so the slope of the best fit line will be a slope of 1. So we're halfway there because that red line did have a slope 1. Then the y-intercept, B0, was y bar minus B1 times x bar. Okay, that's I can't do the share screen, but that's what we said in the notes right there. So let's figure out that. So then B sub 0 is y bar, so 3, minus B1, so minus the slope, which is 1, times x bar, which is 2. Okay, so we've got 3 minus 1 times 2, which is 3 minus 2, and so that equals 1. Okay, so what that shows now is if, let's say I didn't know, we didn't have that in the first place, right? And yeah, notice none of that, I can erase it. We found this earlier, but that stuff didn't rely on any of this earlier table, right? That first table we did up top was just an exploration of this sort of arbitrarily chosen red line. It's a line that goes through the data. Let's just use it for practice to see what the squared errors add up to, right? They happen to add up to 6. Then we compared that to one other example whose squared errors added up to 8. So at that point, we knew the red line here that we had is better than that other example, right? Because remember, we want the smallest sum of those squares. So the red sum 6 was smaller than the other one. So that was good, but we still didn't know if it was perfect or not. So then what we did over all this stuff is I didn't use any of that data from the y hat, notice. All this stuff came from just x and y. From there, we could find the means, x bar, y bar. Once we know means, we can find deviations. Once we know deviations, we can square them or multiply them together, right? Once we do that, we can add them up. And then once we do that, we can figure out what these s sub x's, s sub xy's are and use those to find the exact values that make our line of best fit or our regression line, okay? So now that we've got it, I can label it y hat as our regression line is equal to, and I'll go in the form that they do, so b0 plus b1x. And so b0 is 1, plus the slope b1 is also 1. So you could write 1 plus 1 times x, or you could simplify 1 plus x, okay? So yeah, so that's how it goes. That's it, okay? So it's a little bit, it looks like a lot, but once you get involved and start doing it, it kind of flows. If I haven't mentioned this before about things like this, tables, formulas, I find it fun to work through this process. If you have a small amount of data here, like 3 points, and you do this and get the line, then let's say we never had graphed this line in the beginning, then you could graph it and be like, oh yeah, that looks pretty good, right? That lands between those. For some of the homeworks, you're going to have a lot more points, so that might become not feasible. But anyway, here we go. So let me end this recording.